I welcome you to the second session of permutation and combinations. In this session, we will solve some basic questions on arrangements. But before the basic questions, we must know that factorial n is equal to n minus 1, n minus 2, n minus 3 and so on till 1, which is basically a continued product of all natural numbers from 1 to n. So factorial 6 is equal to 6 into 5 into 4 into 3 into 2 into 1, which is equal to 720. Pn comma r is nothing but permutation of n things taken r at a time, which is also represented as npr is equal to factorial of n upon factorial of n minus r. Cn comma r, which is equal to the combination of n things taken r at a time, is also represented as ncr is equal to factorial of n upon factorial of n minus r upon factorial of r. Now, before solving questions on permutation combination, I advise all the students to ensure that you know how to calculate NPR and NCR given N and R respectively. If you are not able to calculate this, stop this video here. Take random values of NPR and NCR. N should always be greater than R. Calculate, practice the calculation, and then move forward. The number of permutation of n things taken r at a time is given by npr, which is equal to factorial of n upon factorial of n minus r. And you must remember that n is always greater than r. So let us apply this understanding. Again, the advice is students should commit this formula to memory before proceeding any further. Let us apply it. In how many ways can one arrange 6 people on 8 seats? Now this question can be solved both by fundamental principle of counting as well as the formula that I just now shared with all of you. Let us first solve it with the fundamental principle of counting. We have to arrange people on seats. Since there are less number of people, they can choose seats. Had the number of seats been less, it would have been seats who would have chose the people. The first person has 8 choices. So he can choose 8 seats in 8 ways. The second person has 7 choices. The third person has 6 choices because these people are occupying the seats now. The fourth person will have 5 seats because 4 of them have already been occupied. The fifth person will have 4 seats and the sixth person will have 3 seats. So remember, there are 6 jobs in all which are required to be completed. And each job is getting one person seated. And because all of them have to be performed, therefore, there is an and in between all of them. So 8 into 7 into 6 into 5 into 4 into 3 is equal to 20160. So 20,160 ways of seating 6 people on 8 seats. So this was the solution from fundamental principle of counting. But we can directly apply the formula that I just shared with you. The number of permutations of n things taken r at a time is given by npr, where n is greater than r. Here n is the number of seats, 8 seats, and r is the number of people. So the number of ways of arranging 6 people on 8 seats is given by 8p6, which is equal to 8 into 7 into 6 into 5 into 4 into 3, which is basically the same quantity as above, 20,160. Let us solve another question. How many different signals can be made by 6 flags from 8 flags of different colors? Again, we can solve this also from fundamental principle of counting, but we can directly apply the formula. There are 6 flags and 8 flags of different colors. A signal has to be made by 6 flags. So n is equal to 8 and r is equal to 6. Out of 8 colors, 6 have to be chosen at a time. So in how many ways can this be done? 8p6. So which is equal to 8 into 7 into 6 into 5 into 4 into 3, which is equal to 20,160. So this question and the previous question are fundamentally the same question, only the storylines are different. In how many ways can you arrange the letters of the word Bhopal? This is very similar to the seating problem. We have 6 letters in the word Bhopal and each letter has one seat. So the question reduces to, in how many ways can you arrange 6 letters on 6 places? So obviously 6 letters need to be arranged on 6 seats, and this can be done in 6p6 ways, which is equal to factorial of 6 and which is equal to 720. In how many ways can you arrange the letters of the word Bhopal so that each arrangement starts with letter B and ends with letter L? Let us draw a pictorial representation of the same. So we have 6 positions for 6 letters of the word Bhopal. Positions of B and L are fixed. B is at the starting, L is at the end. In between there are 4 letters and these 4 letters can be arranged at any of these in between seats. So obviously 4 letters and 4 seats. In how many ways can we do that? We can do that in 4p4 ways, which is factorial 4. The next formula is the number of permutations of n things taken r at a time so that each one of them may be repeated any number of times is given by n to the power of r. Before this, when we had the number of permutations of n things taken r at a time, repetitions were not allowed. In this case, repetitions are allowed. So let us see how the question changes when the repetitions are allowed. A man has 4 pockets and 3 mobiles of different ways. In how many ways can he place mobiles in his pockets if it is known that each of the man's pocket is large enough to hold any number of mobiles? So we have to place mobiles in the pockets. So each mobile has 4 pockets or 4 choices of pockets. So first mobile, 4 choices of pockets in fact. Second mobile has again 4 choices of pockets. And the third mobile also has 4 choices of pockets. And we have to place all of them. So all the 3 jobs have to be done. And therefore it can be done in 4 into 4 into 4, that is 4 to the power of 3, that is equal to 64 ways. Here n is equal to 4 and r is equal to 3. So 4 cube gives you 64. How many 3-digit numbers can be formed from the digits 1, 2, 3, 4, 5, 6 if repetition of digits is allowed? Again, we have 3 seats. Each digit may be filled in 6 ways. So because there are 3 digits 1, 2 and 3, each of the digit can be filled in 6 ways. The first digit has 6 choices, and because repetition is allowed, even the second digit has 6 choices and the third digit also has 6 choices. So 3-digit numbers can be formed from the digits 1, 2, 3, 4, 5, 6 in 6 into 6 into 6, that is 216 ways. So with this we come to an end of the second session on permutation combination. If you have any feedback or any query, feel free to write to us at studentservices@pfindia.com. Thank you.